Very good morning to you students. Today I'm going to discuss with you the divergence of a vector point function. So far we have discussed the gradient of a scalar function. Now to define divergence we have to consider a vector, not a scalar function. So here you have v bar. Let v bar be a differentiable vector point function, means v bar here is a vector function which is differentiable. Then how they define divergence of v bar is defined as del bar dot of vector v bar. This dot here stands for the scalar product, or it is written as divergence of v bar. So, and it is defined to be divergence of v bar is called to del dot of v bar, which is, but we know what is the operator del. It is nothing but I del del x plus j del del y plus k del del z dot of vector v bar, which is equal to I del v bar del x plus j dot del v bar del y plus k dot del v bar del z. So in this case we will have divergence of a vector point function is a scalar quantity, because when you take the scalar product, v bar here is a vector point function, so the scalar product of this I cap with any vector will give you a scalar quantity. So whereas in gradient you have gradient of a scalar function, you have v is a scalar function, which then gradient of f bar, f it is just a scalar, is defined to be I del f del x plus j del f del y plus k del f del z. Whereas in divergence, remember, it is a scalar product. This dot stands for del dot v bar. In gradient you have this one, gradient of f is nothing but del of f. Okay, here it should be divergence, it is del dot v bar, where del dot stands for the gradient of a vector function. Now if in the theorem, if you have v bar is equal to v1i, it should be a vector function which is differentiable. This vector v bar is a differentiable function which can be expressed in the form of ijk, that is v1i plus v2j plus v3k. Then show that divergence of v bar, which is equal to del dot v bar, is equal to del v1 del x. As you can see here, it is a scalar quantity. Let us show the proof here, how they prove it. So you have v bar it is equal to v1i plus v2j plus v3k cap. Now what we have to find is, therefore, del v bar, you differentiate this with respect to x, del v bar del x, what will you get? You'll get del v1 del x into I, differentiate each of this component with respect to x, del v2 del y into j plus del v3 del z into into x with respect to x, it is with respect to x into k cap. Now you take, what we need is, by this definition, I dot del v bar del x. So here therefore you apply this scalar product on this. So you have I dot del v bar del x will be equal to I dot of this del v1 del x into I plus del v2 del x into j plus del v3 del x into k cap, and this is equal to this del v1 del x. It is a scalar quantity, so you can remove it. It is independent of vector. It is independent of vector, so you have del v1 del x into I dot I, okay, plus del v2 del x into I dot j plus del v3 del x into I dot k. But what is I dot I dot I? I dot I is equal to 1, so you have this is del v1 del x plus what is I dot j? I dot j is equal to 0, so this whole thing will become 0, since you can write I dot I is equal to 1, I dot j is equal to 0, which is same as I dot k. Okay, so this implies that I dot of del v1 del v bar del x is nothing but del v1 del x. Now again you differentiate this v bar with respect to y. Similarly, in the same method you apply del v bar del y I dot j dot del v bar del y will be equal to del v2 del y, and k dot del v bar del z will be equal to del v3 del set. So what you have to do is you substitute what is del v1, del x. What we have to show is that this is equal to this. So therefore divergence of v bar, which is equal to, what is divergence of v bar? It is, as you can see in the definition, it is I dot del v bar del x plus, you see the definition here, it is I dot del v bar del x plus j dot will v bar. So I'll just replace it here. So you have here j dot del v bar del y plus k dot del v bar del z. But what is I dot del v bar del x from here? I dot del v bar del x is equal to del v1 del x. As you can see here, it is del v1 del x. So I'll replace it by del v1 del x plus, what is j dot del v bar del y? It is equal to del v2 del y plus k dot del v bar del y is equal to del v3 del z. So this implies that del dot v bar, that is divergent of this vector function, is nothing but del v1 del x plus del v2 del y plus del v3 del x, del v3 del z. Now we come to solenoidal vector. This vector v bar is said to be solenoidal if divergence of vector v bar is equal to 0, that is del dot v bar is equal to 0. So if the divergence of any vector, differentiable vector function is equal to 0, then that vector is called a solenoidal vector. So next we come to the next definition, that is curl of a vector. Curl of a vector point function. So we have defined divergence. What is divergent? It is del dot v bar. And now next we define what is a curl of a vector function. It is again the same definition. You have f is a differentiable, let f bar be a differentiable vector point function. Then curl, or in some textbook they call rotation, of f bar, written as del cross f bar. This is the cross product or curl of f bar or rod of f bar, is defined as curl of f bar is equal to del cross f, and we know that del here it stands for I del x plus j del f y plus k del z cross of f bar, which is nothing but I cross del f bar del x plus j cross del f bar del y plus k cross del f bar del z. And it should be noted that this curl of a vector function is nothing but again a vector function, whereas in divergence it is a scalar function. So if you have this one, if f bar is equal to f1i plus f2j plus f3k cap, then curl of f bar is defined as del cross f, which is equal to I cross del f bar del x plus I cross plus j cross del f bar del y plus k cross del f bar del z. This is same as I cross. What is f bar? F bar is this, you replace it by, so del x of f1i plus f2j plus f3k plus j cross del y of this one plus k cross del z of f1i plus f2j plus f3k. Okay, now as you know that, so this gives you, I'll just do the first part, the rest will follow the same only. So I cross del f1 del x into I plus del f2 del x into j plus del f3 del x plus del f3 del x into k cap plus dash dash. Similarly for the rest, this one. Now this is equal to I cross I gives you 0. So what we have is this, I cross I will give you 0, but I cross j gives you minus, I cross j gives you k. So you have I cross j gives you k, so you have k into del f2 del x minus I cross k gives you minus j. So you have del f3 del f3 del x. Similarly with the rest also you will get this result. J cross I will give you minus k, so you'll get minus k into del f1 del y minus a plus k, because j cross j gives you 0, but j cross k gives you I, so plus I here you will have del f3 del y, and then plus with this k product here, k cross I gives you it gives you j only, j del f1 del z, and then minus k cross j gives you minus I into del f2 del z, del f2 del z. So you have this result, how it follows from here, because I cross del x f1 I, this one, I cross I gives you 0, j cross j also the same, where I cross j gives you k, j cross k gives you I, and then k cross I gives you minus, give you j, and j cross I gives you minus k cross j gives you minus I, and I cross k gives you minus j. So use that operation. So we have here, so therefore we have curl of a vector f bar is nothing but equal to this one. Curl of f bar is nothing but curl of f bar is equal to del f3 del y minus del f2 del z by arranging the coefficient of I plus del f1 del z minus del f3 del x into j plus del f2 del x minus del f1 del y into k cap. I hope it is clear to you. So with the same definition also you can define curl in term of f bar del cross f. You can express it in Cartesian form, where the first row you write I, j and k, the second row you express this del x, del y, del z, and the third row you write down the coefficient of I, j, k of f, that is f1, f2, f3. Now use the determinant rule, you will get the same result, that is this one, del f3 del y minus all this thing. Therefore curl of f, instead of expressing in this way, you can use this determinant rule, where the first row should be the component I, j, k, the second row will give you the partial derivatives of this That is del del x, the coefficient of ijk of this operator f, and the third row will be the coefficient of ijk of vector f bar. So which gives you the same result.